let's change gears and take a look at when we have a function. We start with the definition of relation. A relation is a set of ordered pairs, a mapping of an x with a y. This could be displayed as a graph, table of values, or an equation. With relations, there are no conditions imposed, so any mapping of x's and y's are relations. A function, though, is a special kind of relation. Here we do impose a condition, and that is that each x gets assigned to exactly one y value. We define the domain to be the set of x's and the range to be the set of y's for our function. Now, if each x is to have only one y, then all of the x coordinates will need to be different. For the second example, the second and third point have the same x coordinate. This x coordinate of 2 is then mapped to two different y coordinates, 3 and 4. This violates the definition of a function. If we're given the graph to test to see if it's a function, we can use what we call the vertical line test. If all vertical lines drawn only intersect the graph at one point, all of the x's are different. If a vertical line hits more than one point, it is capturing those places on the graph where x's are repeated. So for our third and fourth graph, the vertical line intersects the graphs at more than one point in many places, so only 1 and 2 are functions. Determining if equations are functions is much more difficult than working with ordered pairs or graphs. The first equation is a horizontal line. This would pass the vertical line test. The second is a vertical line and would not pass the vertical line test. For the third relation, every x squared gives a unique value. You cannot square a number and get two different numbers. As for the fourth, squaring two different y's, like 2 and -2, will give the same value. So the fourth relation is not a function. Let's talk about a notation that we can use with functions. Here we have 4 functions, solve for y. If I wanted to reference one of the functions, we could number them, or we could use function notation. The notation replaces y, so it means y, and we read it as f of x or g of x, etc. The letters allow us to name our functions. The of x part lets us know what the independent variable is. If I need you to evaluate a function at a value, I would use this function notation. For example, f of 3 is saying to use the function f of x and substitute 3 in for x. What we find is f of 3 is 4. The x coordinate is 3 with a y coordinate of 4. P of 7 says to substitute 7 in for x into the function p of x. When x is 7, y is 103. And I bet you can figure out the last one on your own. In this lesson, we have defined functions, and we've come up with ways to determine when we have one or don't have one. We also introduced function notation and should possibly expect to work with function notation for the rest of our math experience. Thank you for listening.